3. Hello everyone, my name is Vibhavasri. I am from SRT College. Today I am going to tell about the drift current and diffusion current. First we have to know what is drift current. Drift current refers to a movement of the charge carries electrons or holes in the semiconductors due to the electric field. When an electric field is applied to any materials, if it experience a force on the charge carries, causing them to move in a specific direction. The momentum, this movement is called as a drift current. Here is more details. Diffusion. First, direction. The direction of the current is opposite to the electric. The direction of the drift current is opposite to the electric field for the electrons, since they are the negative charge, and in the same direction for the holes since they are the positive charge. Next, dependence. The magnetic field of the drift current depends upon the electric field strength, the mobility of the charge carries, and the concentration of the carries. It can be declared by this equation. JD is equals to sigma E is equals to QU by MUE, where JD is a drift current density, sigma E is a conductivity, E is the electric field, Q is the charge of the carriers, and N is the carrier's concentration, and Mu is the mobility of the charge carries. Here we can see the drift current mechanism. In this way, electric field was applied. We can see here flow of the electron is opposite to the electric field, and flow of holes also are in same direction of the electric field. Next, properties of the drift current. The electric field dependence. Drift current is directly proportional to the strength of the applied electric field. A strong field accelerates charge carries more increases in the current. Carrier mobility. The speed at which charge carries electrons or holes move under the influence of the electric field depends on the mobility. Mu. Materials with a higher mobility exhibits greater drift current for the same field strength. Third, temperature sensitivity. Mobility decreases with the increasing temperature due to the increasing lattice scattering, which can be reduced drift current unless carrier concentration increase the sequentially. Now I am going to tell what is diffusion current. Diffusion current is, on the other hand, arise from the movement of the charge carries from the regions of the higher concentration to the region of the lower concentration, driven by the concentration gradient. This is similar to how the gas diffusion in the rooms. Next, direction. The direction of the drift current is from the higher concentration to the lower concentration independently on the electric field direction. Dependence. The diffusion current depends upon the concentration of gradient and the diffusion coefficients. The equation for the diffusion current density is Jn is equals to minus Qdn by fract dn dx, where Gn is a diffusion current density for the electrons, dn is a diffusion coefficient for the electrons, and by fract dn dx is a gradient of electrons concentration. Here we can see the drift current examples. Here this is how when the electric field was not applied. Here when the electric field was applied. Next, properties of the diffusion current. Concentration gradient dependence. Diffusion current is proportional to the slipness of the carrier concentration gradient. A large difference in the concentration over a shorter distance increasing the current. Second, temperature influence. Diffusion current increases with the temperature because the diffusion coefficients arise with the terminal energy, enhancing the carrier moment. Third, diffusion coefficient. The rate of the diffusion is governed by the diffusion coefficients d, which depends upon the type of carriers and material. Properties it's related to the mobility via that Einstein related d is equals to mu frac k t cube, where k is in a Boltzmann's constant, t is in a temperature, and q is in a charge carries. Last, the key difference between the drift current and diffusion current. The direction. First direction, diffusion current can be controlled by the alternating the electric field, while diffusion current is determined by the spectral distributions of the charge carriers. Driven force. Drift current is driven by the electric field whenever the diffusion current is driven by the concentration gradient. In many practical devices, diodes, transistors, both drift and diffusion currents occurs simultaneously, and understanding their interplays is crucial for the semiconductor device in physics. And thank you.